what we do is we generate this query builder by introspecting your schema, like from your live database, pull out like all of the object types in your schema and their properties and how they link to each other. And then you can just like start building queries.
Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey everyone, today's guest is Colin McDonnell. Colin is the head of developer relations at EdgeDB and the creator of Zod, which is a TypeScript validation library. He also created tRPC, and we talked to Alex Johansson back in episode 21 about that. So Colin, it's really amazing to have you here with us. I'm really excited for this conversation, especially as a huge fan of Zod in particular. So it'll be awesome to talk to you. Is there anything you would like to tell our listeners about yourself?
Yeah, well, first of all, it's great to be here. Thank you so much for having me. This show really exploded onto the scene, and it's been great to see. There's definitely a lot of latent demand for, getting some insight into how OSS kind of happens and the people behind it. And so this is definitely scratch an itch for me. So thank you for doing this. Yeah, let's see. On the tRPC front, just to give Alex credit where it's due, I made a proof of concept there, very quickly. You can still go back in the Git repo and kind of see what that looked like. And then he just took it and really turned it into what it is today. And he also was already working on kind of something with the same kind of design goals already on his own. So I think he recognized, the value in having the tRPC NPM package name a little bit, and also, liked the kind of approach I was going with. And then, that was another great episode, and definitely encourage more tRPC usage, because one of the things I've been getting a little bothered about is how tricky it is still to actually build end-to-end type-safe applications without something like tRPC, and how much kind of plumbing you have to do with API routes or whatever to you have to extract out the return type of get server-side props or whatever, and then pass it into your page component or whatever. All of that kind of it's a little bother, but I think things need to get a little better there, and tRPC's doing a good job of that. Sorry, big diversion. That didn't answer the question at all. Yeah, you kind of covered everything for me. Head of developer relations at EdgeDB, which we'll talk a little bit about at the end. But then before that, I was, I've been an open sourcer, I guess, for just over 2 years now, and just kind of fell into it, starting off with Zod, which I'm sure we'll talk about here more in a sec.
Yeah, so let's go into your background a little more. In the notes you sent me, you mentioned that you were part of the YC19 class, and I noticed that happened at the end of you being a digital nomad. So, what was your YC idea? How did you get there, and where is it now?
Yeah, for sure. So, I was a bit of a contrarian coming out of college. I graduated in 2016, and kind of tried to force myself to take a more interesting path by not really getting a job and up until recently. I would say on net, wouldn't recommend this path to people. I kind of naturally fell into the indie hacker digital nomad set, just because was increasingly more of a bit of a well-trodden path around 2016, 2017. I think that's around when indiehackers.com kind of got big. And, it's a fun place to be. And I think I appreciate the idea of people just trying to build kind of very niche software and make some money for themselves, and not necessarily try to be some billionaire startup founder. I appreciate there's a degree of pragmatism in that community that I like. But the things that I ended up working on were pretty dumb, I would say. I mean, objectively, you can look at my product hunt history. I made a journaling app that would fine you if you didn't journal every day, and called journalorelse.com. Very silly. It's also now defunct, so hopefully this doesn't result in a surge in demand for this non-existent product. I had a weirdly long period of time where I was trying to generate trivia apps for iOS, which was a fun technical project because they don't make it super easy. There's a project called Fastlane that tries to provide some automation tooling for the iOS app build process. And I would scrape information from Wikipedia info boxes and stuff. So I don't know, it's kind of like not, it's kind of like sketchy. It's like kind of dumb, the things that I worked on. And so eventually I tried to go legit a little more. And, you know, by kind of total coincidence, I ended up going to a conference with my aunt, who at the time was starting a medical practice, a specific kind of medical practice called direct primary care, which was kind of getting bigger at the time. I think, you know, awareness of it has kind of slowly ticked up over the past few years as, you know, it's increasingly clear how insanely unsustainable the insurance-based healthcare system is. And it's basically doctors that are just like, you know, kind of have a bit of a entrepreneurial libertarian bent, and they kind of are just like taking this burn it down approach where they are starting practices that don't accept any insurance and instead have like a membership model. So kind of SaaS-ish as well in that sense, where basically this membership fee that comes in is like their actual source of revenue really, and then all their other services they kind of provide them at cost as cheaply as possible. And you know, they also try to negotiate cash rates from, you know, on medications, which can actually get really cheap if you're not paying through insurance. Same for like x-rays and, you know, more like scans like that. So all told, you know, I think it's an interesting model. It's currently kind of like kneecapped because you can't actually, you know, this 75 or $100 a month, however much the membership is, you know, it's affordable compared to how much your insurance plan costs, but it doesn't feel that way because that's all coming out of pocket. Whereas your insurance is usually paid for by your employer and you don't have to really bear the brunt of that. So it feels like you have to pay for two things instead of one. And so it's kind of like a fatal flaw at the moment. But, you know, it's still growing like pretty consistently year on year. Anyway, the actual startup idea here is just building the kind of all-in-one software platform for that. Specifically, the kind of existing options don't serve their needs very well because they actually have to do like credit card style membership management, just like any SaaS software would, which is not something that is baked into your, you know, big medical record softwares as you'd probably expect. And so I figured that would be enough of an angle to kind of start, you know, building a software that would be specifically appealing to this sub community, which at the time was like maybe 500 practices nationwide. You know, I was drawn to this idea in this community because it was very small, and no one else was really building anything for it at the time. So, you know, I liked how much of it's kind of like a low risk, low reward kind of startup idea. Of course, in the YC interview, I'm like, you know, I took this growth trend for the number of DPC practices, which at the time was like, you know, there was like 200 and then 400 a year ago and then 600 now. And I was like, so naturally we're going to be plotting this on an exponential curve. And in 10 years, it'll be every practice in America. But in practice, it's grown almost on a perfect line, not exponential at all. But, you know, no need for YC to know that in the interview.
And where did that end up? Did the startups kind of fizzle out? Like what? I don't really know what happens with YC. If they invest and nothing happens, do you just get to walk away?
Yeah, fizzle out is right. So yeah, I basically, you know, did YC winter 19, so like January to March, and then got out of the Bay Area and went to San Diego to try to hack on it for a while. And basically by like September, so like 9 months in of working on this software, like as a solo dev, basically just like couldn't stand the sight of it anymore, like burned out totally, and had zero motivation to keep working on it. The main thing that I did wrong here is not like cutting and running at that stage, I would say, because I kind of like, I didn't like go get a job. I didn't like shut it down. Actually, I still haven't shut it down, this business that's on the to-do list for 2021 or 2022, yikes. But yeah, I just, you know, it was a big project. I was maybe like 40% done after 9 months. And I was like, you know, kind of faced with this realization that it'll take like, you know, a really long time to actually build this thing properly. And yeah, just kind of like, I made some bad technical decisions too, which we'll talk about with regards to the origins of Zod. That just kind of made this all the application was like, kind of got less and less stable over time as complexity increased. I think now actually the tooling exists to build this in like a really fantastically type safe, like nicely structured way. But at the time didn't so much. And yeah, you know, kind of like, you know, in September kind of stopped working on it actively, but was still kind of puttering around trying to like get motivated and working on side projects and stuff to try to kind of weasel my way back into working on it more regularly. One of which kind of indirectly was Zod. So yeah, I mean, I'm alluding to this bad technical decision I made, which was I tried to build this entire software on Neo4j, the graph database, which, it's not really intended for being the back end of a kind of application like this. You go to their site and they're like, oh, graph databases, it's great for like analytics and like importing in these big blobby unstructured databases, but being able to pull insights out of them, because it's totally schemaless, essentially. You just got nodes and edges. You can attach some labels to the nodes and some labels to the edges and properties and things like that. But, at the end of the day, because my database was providing no type safety for me in the way that like a relational database would, I had to just be like very careful about the data that I wrote into the database to make sure that it still conformed to anything resembling what I expected it to be and what my application code expected it to be. And so, as you might expect, this led pretty directly to Zod, which is, I started playing with different schema libraries just to validate my kind of incoming payloads and make sure that they, conform to these kind of server-side models that I was enforcing before any database write. And, kind of just had issues with the ergonomics of all the libraries I found, which at that time was like, there was Yup, there was Joy, which never really made the leap to TypeScript, and then IOTS is a big one. And, a smattering of others, like Superstruct by the legendary Ian Storm Taylor, which it was also always intended to be a little more minimal, less full-featured, but is still a very fast option for people who, are prioritizing performance over expressivity. Yeah, and so, I started making Zod. There's really like maybe 1.5 features that Zod included that were really the only major points of discrimination between the other ones when I first published it. Specifically, like, it kind of had this IOTS style thing where you import the library as like a single variable. It's like Z. In IOTS, you import it as T. And then IOTS was almost perfect, except for how it kind of made it tricky to declare partial, objects with optional fields, where you had to actually like split up the object type into, the required properties and the non-required ones, and then union that together. Whereas Zod made a decision that is actually increasingly controversial, which is, you can just, in your object schema, you can do z.object, parentheses, braces, and then in there do like username : z.string .optional, and it'll treat that as an optional property. And I mean that in a kind of specific TypeScript-y way, which is, it'll be as if you declared a type, name : string, which means that when you're creating, an object that conforms to this type, you can just leave, I think I switched from username to name or something, but you can just leave that field out entirely from the object if you've got that question mark, which...
Why is that?
Unfortunately, TypeScript 4.6 made this controversial because they introduced something called exact optional property types as a flag that you can enable in tsconfig, which is, there's basically now like 3 different types of optionality, like 3 different senses in which a property can be optional in a TypeScript object. So you could have like, in your object type as a field, you can have like name : string, in which case you can either you can assign a string to name or you can leave it out of the object entirely. You can't assign it to just the value undefined under this new exact optional property types, and it doesn't allow that. So then you'd actually have to do name : string or undefined if you want to be able to assign it that value of undefined. And then the third option would be getting rid of the question mark, in which case you'd have to assign it to be either undefined. You can't just leave it out of the object. So it's kind of like this 2x2 grid now with optionality, where there's like the question mark version of optionality, and then there's the, or undefined version of optionality. And you can do one or the other or both. And Zod only has one conception of it, which in this case it treats it as it's basically the version that has both the question mark and the or undefined. So you can assign it to, undefined or not at all. And yeah, people, this is now that issue got opened, the day TypeScript 4.6 landed, of like, oh, this doesn't really align anymore with exact optional property types. And I'm like, yeah, that's sucks to suck. I don't really have a fix. This, it's kind of like now built in structurally into Zod. So I don't know.
Yeah, it's a challenging part of like an evolving type system, right? It's like sometimes you make assumptions based on how a type system operates, and then it changes.
Yes, for sure. For the most part, progress has been in the direction of much greater convenience for me, with like the recent stuff with better like, recursive conditional types and things like that have made, I used to have to use these nasty hacks that the TypeScript team like explicitly condemn in order to make some of this stuff work. Maybe you shouldn't admit to this, but now it's all, above board for the most part.
Nice. So one of the things that I think is like very true of development in general, and interesting, it'd be an interesting question to relate back to your talking about your experience of your startup, is that there's a lot of incidental complexity in building apps. And a lot of the times it's trying to pipe together and verify types between different layers in our software system. So it's like you have types in your database or not, as the Neo4j case. And then you have like types in your backend system, types for your API, types for your front end system. And it's like, in the worst case, all of these types are different, or in the worst case, they're all like very, very loose. So it's where things like Zod can really help, at least saying, hey, I'm going to take in this like loose blob, but this is like how I expect it to be formatted or whatever. So I'm curious if this problem was what really, so obviously the Neo4j experience is like a big foundational inspiration for Zod, but is that also what sort of spurred your exploration into tRPC, that early prototype? And then, is this something that you still think about maybe more holistically than even just like the Zod layer?
With certainty.
Out of curiosity.
Building on Neo4j wasn't the only problem with how I was architecting this massively complex medical software with like 100, data types and stuff. Basically I started off learning TypeScript when I started building this application. I was like, all right, I'm in this for the long haul and I'm going to like do it the right way. And then I, immediately proceeded to do most things in the wrong way. Specifically, like, I don't know how I kind of built my own semi-typed ORM on top of Neo4j that let me do things like nested fetching in a, painless way, which, isn't particularly painless in Neo4j. Well, I don't know if that's fair to say, but it let me, have like an ORM layer that would give me a strongly typed result. Except I say that with like major air quotes because none of the properties on an object were typed, only the relationships between nodes were typed. I don't really know how I just didn't know enough about TypeScript to, implement this properly, I guess, at the time. And so, yeah, basically none of the actual like properties on any API payload I had on my client side had any types on them, which was a big contributor to this kind of bad, this growing instability as complexity increased. And over time, it felt like everything I did would just like break everything at runtime too, not even, at the TypeScript layer. And I think the main appeal of TypeScript when you have like full end-to-end type safety is that your code base feels very crystalline. It feels like everything that goes wrong, it'll tell you immediately before you build it and encounter that issue at runtime. And that feeling of like crystalline code bases is something that, like, as a result of this very painful months-long experience that I had building this app, I just became allergic to anything that didn't feel like completely type safe. And, that kind of emerged after I stopped working on this and like started playing around with how to actually build like a fully type safe, fully dry application was kind of like a multi-tier or multi-month effort. And Zod was kind of the first volley in that, and tRPC followed swiftly. It actually was the original motivation came from a friend of mine who built a tiny project called Obvious RPC, which doesn't have any of the tRPC kind of notion of like a router where you define your routers by chaining together calls to dot route. You actually just like, it's all kind of file system style, like routing style, where you've got like your functions that you're declaring on the server, and then you are able to like import this big kind of like hierarchy of functions just as a type. And this was actually before import type was even a thing. So what you would do is like you'd import all the functions client side. You would do like with a dynamic import. So you do like const, client equals type of import parentheses, and then import, everything from your kind of like hierarchy of server-side functions, if that makes sense. Definitely check out Obvious RPC on GitHub, because, it was definitely like an inspiration for this level of type safety. And then, there was some other things as well, like things that I liked in the GraphQL ecosystem where they would do kind of automatic normalization, like it's been a while, but Apollo does this, Apollo client, where, as data comes back from your GraphQL API, they only store one copy of each object on your entire client. And so as like different payloads come back from different, URLs, it's able to like look at the type name and look at the ID, and then just kind of like automatically update the like single source of truth for that given object. So I implemented a project, that did something similar to that. And I think with the combination of like Zod to validate incoming inputs, tRPC to actually implement your API in a type safe way, and then some sort of database client that lets you, fetch strongly typed, stuff from your database without necessarily needing to worry about, without having to like separately validate it, something that just like works and infers that type from your query. Prisma is the obvious one here that did this right, like really correctly for the first time. Though the EdgeQL query builder that I'm working on now at EdgeDB is, I think, kind of the next iteration of that, and in terms of like power and type safety as well. So the combination of those three things is like this trifecta. And I think even with tRPC growing in momentum a lot, most people aren't like necessarily building something that is totally type safe and totally dry. But I think we're moving in the right direction.
Something that's interesting to me about this space is the idea of sort of like implicit APIs, and you can sort of see it come up in meta frameworks. So the one that jumps out to me most is the work that Blitz.js did to make like, in your client, just import your server code, your server module, and it automatically like builds an RPC client for you behind the scenes, at build time that you never really see. The only caveat is like you have to make sure that the things you're returning are serializable or whatever, so it's a little leaky, but that idea of like, it's just TypeScript code, you're using it everywhere like you normally use it, and then it like magics an API for you is kind of nice. But you see lesser versions of this in like Remix, which has like loader functions and actions that are in your front end code basically, but they're compiled out to server-side modules, or even Next.js with like get server props and all that stuff is a similar sort of concept of like they're APIs, but they try not to feel like APIs, if you know what I'm saying. It like tries to reduce that like cognitive overhead of forming a type and then having to like parse the type and understand that like what's coming back. If you have a system that's just it's a one-to-one mapping between a front end and a back end. It's like a unified system. You can have this sort of back end for the front end that's unified in a way that's nice. Obviously, it's hard to do that universally, and I'm glad for like tools like Zod and tRPC, which like meet you, where you're at, kind of, and help you like, build out what you need, especially in systems that are traditional APIs like REST APIs or something. Zod is definitely a godsend. But I'm really interested to hear more about your work at EdgeDB, and especially this like query language that you're working on. It's like, and how that sort of plays into this overall story.
Yeah, for sure. On the implicit APIs front, I do want to give some credit to Blitz as well, because they definitely were very early on this notion of, the zero API kind of system. That kind of like paved the way in terms of like how to explain tRPC to people. And also, like, because Blitz was an early adopter of Zod, like a very, very non-trivial fraction of the people who've discovered Zod found it through Blitz. So I really can't, Blitz really helped me in a lot of ways. And, I think it's kind of like pivoting a little bit these days. So I'm curious to see kind of how all that shakes out in this new era of framework wars that's now upon us.
Yeah. I always wanted them to like open source just that one little piece. It's like give us this. I mean, it's out there. You can like pull it out, but it's very specific to Blitz. So it's like,
And I mean, ultimately, I don't really think that the rebundling kind of thesis behind Blitz is likely to happen. Like I think the kind of fact that you pull in like very specific modules from NPM for, building out a specific stack is part of why the JavaScript ecosystem is just so many light years ahead in terms of just concepts, the conceptual. Yeah. I mean, the concepts of how we think about web development compared to, like the Python ecosystem or something that like for the most part is still doing like HTML templating and stuff. Or, I guess PHP is on that, but they're kind of defiantly still doing the HTML templating and, props to them if that's working for them. But yeah, the rebundling, I think it's almost impossible to not end up, becoming the villain a little bit and standing in the way of that kind of pluggability. Yeah, so as for EdgeDB, which you asked about, I've been working at EdgeDB for a little over a year now, and they really knew exactly how to kind of win me over, which is, they just found Zod just on the internet and, identified it as like a, very non-trivial TypeScript project with lots of generics and conditional types and type inference. And they were at the time, well, and still now, looking to build like a TypeScript query builder for EdgeDB's query language, which is called EdgeQL. And I kind of looked at EdgeQL and immediately was like, wow, okay, this is like the way things have to go, because it's kind of like, it is a full-fledged query language, but it basically fixes every like usability concern that I've had with SQL for, as long as I've been like a developer. And it kind of like takes a lot of good ideas as well from GraphQL, which I think is fascinating, where like, you actually have these kind of GraphQL style like shapes, they're called in EdgeQL, to specify like what fields, you want to select. You've got select user or whatever, and then you just put in some curly braces and like pass in the list of properties you want to fetch. It's also not relational in the sense that you don't just have like, a bunch of flat tables that maybe connect to each other with like foreign key constraints and stuff. It's very much like, you're writing your schema the way that you would write like a TypeScript interface, where like, it's object oriented. You just got like your user type, and it maybe has a key like posts that like corresponds to a list of blog posts or something. And so it's like a database that conclusively solves the problems that ORMs are trying to solve. And it all does it in the database, where you've got this like object oriented schema, and then you're able to like do things. I mentioned this kind of GraphQL style selection set, and you're able to do things like select, the name and the email of a user, and then also fetch the posts that it's linked to, and then fetch properties of those posts. And then, this is all just looks like, nested shapes in your query. And so you can, no more joins or anything like that. It's all because you've got that underlying object oriented schema. It just gets really easy to write nested queries and like finally move away from like some of the things that make writing any non-trivial SQL query like pretty intimidating to somebody who comes up writing JavaScript or like comes up, very much in this object-oriented world.
So you work on the query language. Where was it when you like started at EdgeDB, and like what have you brought to the query language that wasn't there before?
So the query language EdgeQL itself was already pretty mature by the time I got there. And my task was specifically writing like the TypeScript version of it that lets you actually write your EdgeQL queries. Instead of, there is a way to write queries to EdgeDB kind of in the old-fashioned way. Like if you've used like a SQL database driver, you like will initialize a client, and then you write your queries just as strings kind of dropped into your source code, which like feels a little weird. You've got these little islands of SQL, they're like probably not syntax highlighted, yada yada. And then you still have to like manually provide a type signature if you're like using the TypeScript client, for instance. And so what we do is, we generate this query builder by introspecting your schema, like from your live database, pull out like all of the object types in your schema and their properties and how they link to each other. We also pull down like all of the like built-in functions that are built into EdgeDB. It's got like a whole standard library of functions. It's got like a whole type system of its own that we kind of try to represent in TypeScript. And then we just generate, it's very similar to Zod in some sense, where we generate this like a bunch of code. You import it all as a single object called E conventionally. And then you can just like start building queries. So like, you can do like e.select, which is just like a function. And then, the first argument to that function is like the object type you want to fetch. So like e.user. And then the second argument is like a closure, a function that kind of like gives you, that this function returns an object that basically specifies like everything you want to fetch, as well as like, your filters and ordered bys and limits and like all these different clauses on your select query, which is something that I think I'm proud of about it relative to something like Prisma. We did this kind of aggressive approach where, you've got this like second argument, which is just like a function that returns an object, this like parameters object. And inside of that function, you specify like the fields you want to select. You can also like do that nestedly, fetch all the blog posts of a given user or something. You can also include computed properties that you can define. So the reason why this second argument is a function that returns an object instead of just an object is, you can take the argument of that function and it basically gives you like a variable that you can use that is a reference to the current scope, like to the user object. So, you would just call it something like u or something. And then you can reference like u.name or u.email, do like, modifications to those with built-in functions like, string conversion functions or this or that. Or if you want to do something like just like count the number of blog posts that a given user has written, then you can do that with e.count, and then pass into that like, u.blogpost or something. And so like, you're able to write like, you have access to this whole query language of EdgeQL, and it's all represented in TypeScript. And then at the end of the day, the result of those queries are fully typed. And there's, the more you start like using something like Prisma, the more you start hitting against the limits of it. I remember being satisfied with Prisma, and I get that people who are completely, but there's over time it gets, we're tending towards a world where, a lot of those things are kind of just not best practices anymore. The things that you have to do with Prisma, or like you'll have to maybe execute multiple queries, in series in order to fetch all the data you want, for instance. Something like, fetching all of the number of blog posts written by a given user, I think is maybe just now supported with this _count API they provided as of pretty recently. But let's say you want to like count the number of blog posts subject to some filter, like the number of published blog posts would be like an obvious one. You can't get that in Prisma. And then, I know this is the JavaScript ecosystem, so performance is rarely, the main thing driving decision making. But like when you start looking, if you turn on Prisma's query log to actually see the SQL queries that it's emitting to your database, it is like, it's remarkably naive, I guess. Like every level of depth in your query, in terms of like nested fetching, that each of those get mapped to like another query that has to get executed in series. And the queries themselves are very verbose, where it fetches like your top level thing, fetches a list of users, takes all of those IDs, and then just like drops them all into this second level of query to fetch like all the blog posts associated with the users with those IDs, and then does a third level to fetch like the comments on those blog posts or whatever. And it's if you have like any amount of latency between your server where this query is getting executed and your database, this has like a multiplicatively bad outcome for you, where a pretty simple looking query will require like 4 to 5 round trips, because you have to all these individual queries that get executed also get run in a transaction. So you've got start transaction, end transaction. And so, most like non-trivial queries require like 4 to 5 round trips. And I was surprised when I learned this, and I learned this relatively recently because we were working on a benchmark at EdgeDB to try to, capture some of these characteristics. And I didn't realize that that's how Prisma did things under the hood. So performance is certainly a consideration. I personally prioritize DX over performance, and which is why I, am also proud to say that I think the DX is better in terms of like being able to express whatever query you want to express, and not be limited to, the kind of CRUD API that, Prisma or whatever ORM kind of gives you out of the box.
Very interesting how natural of a transition that this role is from like your past. I mean, you can sort of see it, like the experimentation with Neo4j and the pain that you felt there, and then the creation of Zod, and now what like EdgeDB is like looking like it's that ultimate. It's like, hey, I want this type safety, but I want it like in my database,
Yeah.
like more actually at the schema level. I think it's interesting because like, I talked again earlier about like, it would be nice if we had more implicit interfaces between things, but I mean, those are always abstractions, right? Or generally those are abstractions and they don't map cleanly. And the problem that you're talking about with Prisma and query performance is like, so Prisma's hitting potential multiple databases, and like, they are creating a generic schema that can target different types of databases with different types of optimizations and stuff. And I mean, a lot of times with an ORM, they are going to take a more of a naive approach, because it's like sometimes writing an optimized query takes, well, A, query optimization can be quite hard. And B, sometimes it just takes implicit knowledge that maybe you don't have at that time, or maybe it's really expensive to compute that or whatever else. So it's just like this leaky abstraction. So building it more into the database is interesting.
For sure. Yeah. I mean, building an ORM, I have a lot of compassion for anyone whose job that is, or who sets out to try to do it, because it's, you are saddled with like this least common denominator problem, where you need to work within not the restraints of one database, but the restraints of every possible database you target. So, they're like, something about EdgeDB that I should mention is it runs as a layer on top of Postgres. So, we try to abstract that from you. Like, you can use EdgeDB and spin up an instance of it, and it will create that Postgres instance under the hood. But, the EdgeQL gets converted to SQL by our query compiler. The EdgeDB process itself is completely stateless. And your schema that you declare with, the EdgeDB schema language gets reflected into like a fully normalized, like relational form under the hood. And, so we still we get to benefit from the performance of the Postgres query engine and like some of their like schema, like just their very powerful schema. But EdgeDB wouldn't work if we tried to target something beyond Postgres. Like there's features that we use and rely on heavily that are literally only available in Postgres, and we like wouldn't be able to pull this off if we were building even on MySQL or Mongo or any of that. And it's a huge benefit to our ability to iterate and build and just like create these features by not having to worry about that least common denominator problem.
That's really interesting. I didn't realize that it was built on Postgres.
We should probably try to emphasize that a little more on the homepage. It's there somewhere.
It is on the homepage.
Yeah,
Totally.
it's nice as a user too, because like with Prisma, like having to understand that it can target these 4 different types of databases and like code your schemas to that. Like, it's weird how often when I'm working on Prisma, I'll end up on one of their docs pages that has nothing to do with Prisma. It's just like, here's how to use Postgres, or here's how to use MySQL. So like the one-to-one mapping is actually kind of nice from a user perspective too.
Yeah, just having one set of conventions for how to do everything. And, Prisma, I think I also don't envy them, in that they've got to delineate what functionality is available now on Mongo versus on the SQL-based ones. And it's like, oof, that's a hard problem just from the standpoint of structuring documentation.
Yeah, I mean, you run into I've like hit those things where it's like I was on Postgres. I was like, oh, I'm just going to switch this to be SQLite. And it's like, oh, wait, this one feature that you're using, that's not supported.
Yeah.
And the other sort of challenge is, so with Prisma, you're writing a schema file. And major props to the Prisma team, because they've built on a lot of amazing tooling, especially around creation of schemas. But you are writing another schema, and then, it can technically generate your database schema or whatever under the hood with some magic tooling. But like there are 2 separate schemas that you have going on there, and like it's a thing that you're very aware of, or you should be very aware of.
Yeah. Without a doubt, we took some cues from Prisma and continue to do so in terms of the DX that they're kind of pioneering. I mean, the fact that it was an ORM that defined its own schema definition language was pretty baller and, important for what they're trying to do. We have the same, and with the major difference / benefit, which is that inside of your schema for EdgeDB, you have access to the kind of full power of EdgeQL as well, like a full schema language. So things like putting in like computed fields inside your schema definition is possible. Prisma's also like, they've had a tricky battle where they need to strike a balance between their object-oriented abstraction and the relational abstraction. And they know that it necessarily has to be leaky, where people are going to be falling back down to writing raw SQL. And so, which is the origin of this decision they made to kind of like, you still are declaring your foreign keys a lot of times. So you've got your like author link or author field that points to like a user type, but then you also have to put in author ID, and you have to say like, okay, the author, relation should be using this author ID field, because they want that to be explicit in the schema for the people who will need to fall back to, to actually writing raw SQL. And, the solution to that, building a leakless abstraction, like a leakless object-oriented abstraction over SQL, has been the goal of EdgeDB since the outset. And it's extraordinarily difficult. The things that we do to generate SQL that, kind of returns like a nice nested object for you that is kind of familiar to someone who's coming from an ORM library. This is a lot of where like we're really milking Postgres for all it's worth, because we have to do these crazy like subqueries and stuff in order to like write nested queries that are performant and like give you back data from SQL in like that kind of structured JSON format, instead of in the like flat, list of rows thing that then needs to be denormalized. Yeah, it's a lot.
You guys have like similar developer tooling where like with Prisma, you're writing your schema and it kind of is like automatically connecting things together. Does your schema language have a similar like IDE experience?
We're definitely working on the IDE experience. It's tricky because of the power of it, where the IDE would need to be able to like have the entire grammar of EdgeQL baked into it, because our schema language is a superset of our query language, where you can declare your object types and stuff, but because each of these your object types can contain arbitrary EdgeQL queries within them potentially, it gets it, things like auto formatting get a little harder. We have syntax highlighting, but for all the major IDEs, but we're definitely working on like a proper implementation of like the language server protocol that would actually, let us get a little fancier with it.
Yeah, because like you work on a query builder, but as you said, you could write these queries in just like strings. So I'm assuming like right now you guys don't have like a template string thing that helps you with like automatic type completion in there.
Yeah. So if you're writing your queries as strings, then you're on your own. But if you're using the query builder, then everything does get auto-completed for you. Like when you're inside of like, that kind of params object you're writing, you can, this actually relates to one of my tooltips that I'll get to, but, when you're inside of that object, you can, start typing something and it'll autocomplete like every property, for you on that object type, as well as all those different clauses I was talking about, limit, offset, order by, whatever, things like that. I'm not sure I completed this thought, but the fact that, in Prisma, every level of depth, you need two levels of objects to declare it, where like, you've got like prisma.user.findMany or whatever, and then you pass in a params object that contains like, there's like a select or an include like key that you put in, as well as like your limit and offsets, things like that. So you kind of need to put in select and then add another object in there to, tell it which properties to select. I'm not sure exactly why they do this actually, because, well, in EdgeDB, you're not allowed to name a property like limit or offset or something, because those are reserved keywords. And so we just kind of like flatten all that out and just have it all in one object, where, you do have some things that are kind of odd, where you've got like first name true to tell it to select, the first name. And then right underneath that, you would have like, filter, and then like providing a filter expression. But because you can't name a property filter, we just flatten all that out. And so it's a really nice experience keeping like having the levels of depth of your object, of your params object, correspond to levels of depth in your query.
It's really fascinating.
In your notes that you sent to me, you said that you guys basically implemented an entirely different type system within TypeScript. What exactly do you mean by that?
Yeah, this was not trivial. EdgeDB, it's got the kind of types that you'd expect in a database. So it's a little more, there's more to it than TypeScript. So you can provide like, int 16, int 32, int 64, for instance, as like different numerical types. Then there's a date time type. There's actually like a duration type as well, which are things that don't currently have, corresponding types in the TypeScript system. I think there may be a duration type that's a web standard now, or maybe a proposal, but we're not quite there yet. But yeah, and then there's the actual types that you declare in your schema, right? So there's like user and blog post or whatever. Those are types that, well, you know, the idea basically, EdgeDB is kind of interesting in that it has like a basis in set theory, where every value, every like EdgeQL expression that you can write corresponds to a set of values. And that set corresponds with like a type and a cardinality. And so instead of having like in TypeScript, you could have like a string, or you could have like an array of strings. In EdgeDB, it would be like you've got a set of strings and there's a constraint on its cardinality. So, you know, maybe that constraint is that this set contains 0 strings, which would correspond to like, you know, I guess an empty array in TypeScript. Or you can constrain it to only contain 1 string, which corresponds to the string type roughly. Or you could say like this contains like 1 or more or 0 or more, you know, elements in this set, which actually correspond to different types in TypeScript as well. You know, if you have 0 or more strings, that's just an array of strings. If you have 1 or more, you actually would represent that with a tuple in TypeScript, where you've got like, you know, braces, you've got string as the first element, and then you have like a rest parameter, like ... string braces as the second element. And that is kind of in TypeScript how you represent like an array that has to have a single element at least. Not sure if that translated into a podcast form, because it looks a little silly and most people don't use this. But yeah, you know, so basically every single, you know, it's like Zod in that you're using this like API to build up like a data structure that represents something complex. In Zod's case, that's a schema. In this case, it's like, you know, a query, and every expression along the way, all the little pieces that you're composing together here, are objects that conform to this like expression, like EdgeQL expression interface, which just consists of 2 things, which is, you know, that type, like __ type, and __ cardinality. And we track all those things. We write these like crazy generic functions that are able to accept inputs and return a value that has, you know, the appropriately modified type and cardinality. And, you know, lots of crazy generics and overloads for sure. I think there's like 8 or 9 overloads just on the select function, just because there's a bunch of stuff you can select in EdgeQL. And yeah, I mean, it's certainly been like the fact that we're starting off, you know, having to build out this whole new, like generate this whole new type system, and then write a bunch of logic that, you know, is able to track all those things properly, and eventually at the end of the day, convert it all to, you know, an equivalent TypeScript type. It was crazy and awesome, frankly. It was like the most challenging thing I've ever done, and really makes Zod look like a toy a little, you know, in terms of the implementation complexity. There's so much more to like crazy tricks that we used in building this, where like, you know, if you have like an expression that corresponds to like an array of string, or like a set of strings like we were talking about, actually scratch that, an array of strings, because there are also a concept of array and tuple types in EdgeDB that are like, so you can have a set of an array of strings, for instance. So it's not like sets like, yeah, right. It's not like sets, you know, eliminate the need for something like tuples or arrays necessarily. So, you know, if you have like some set corresponding to an array of strings, you can just like index it. Like you can just do like brace, like left brace 1, close, you know, right brace. And that we use the proxy API to basically like, you know, because you're calling this index, you're getting trying to grab the first element of this array. I'm using air quotes because it's not actually an array, it's an object corresponding to a query that corresponds to an array. And so we use the proxy API to basically like capture that incoming like index event, and then we return like a wrapped version of the object of the expression that, you know, you called this index operator on. And like, you know, we take that, we wrap it in another object, which is like, you know, just is an index like operator expression. And so we just like basically have references to like the wrapped expression that you called it on, and then the value of 1, which is like the index in question. And then you take this gigantic object and basically like linearize it out into the corresponding EdgeQL query. So at the end of the day, this all gets turned into like a string, an EdgeQL query string. And then you can just like execute that against your database. Yeah, it's a little nuts. I'm not sure. It is a full query language too. So there's things like parameters that you can pass in, you know, in EdgeQL that's like a $ name or whatever. And so you can kind of take a query and wrap it in e.params, you know, specify what all the inputs are that this query expects. And then when you go to execute that query, there's like, you pass in the data associated with these parameters, and that's all strongly typed as well, because we infer that type. And so it starts feeling like you're executing your queries kind of like functions where like, it's all totally dry. You're able to tell it what parameters are expected, and then it enforces that the data that you pass in actually corresponds with those types. So, I don't know if people have used Connects.js or something, which is probably the closest analog in terms of like a query builder for a query language. That one's all SQL based, and they've done their best in terms of type inference with Connects, but it's pretty limited in what they can do, just because they're limited by like the relational model by SQL itself. Specifically that, what I was saying earlier about how hard it is to actually write a SQL query that returns that kind of structured JSON style output that we're talking about. Like most SQL queries, they're only intended to be like, you'll join tables and you end up with this like big flat list of data, and a lot of it is redundant, and you have to like do a lot of work to turn it into something that looks familiar as a norm user. And it's not even possible in all dialects of SQL. So yeah, I mean, there's really, there's no way for Connects to get around the fact that it's just hamstrung by what SQL actually is.
Okay, so relating to all the stuff you just talked about, what does it feel like to sit atop that TypeScript throne? But in all seriousness, how did you get so good at writing this type of generic code? I talk with a lot of people who are like, I like TypeScript, but like once I get into generics, my head just explodes. So like, how did you get started in that? And do you have any resources that you could point people towards to help learn this type of coding?
Yeah, I'm definitely not on any kind of throne. I think if anything, I've fallen down a cliff and like hit every branch like on the way down. That's kind of what it's felt like. Yeah, I mean, I remember like, for the sake of like, for anybody who feels that way, it was immensely intimidating to me. Like the idea of any generic in TypeScript, like, just a tiny bit over 2 years ago. Like when I set out to build Zod, I didn't know anything like at all. I looked at the implementation of IOTS and like, borrowed a lot of approaches that Julio was using in that library. But like, I remember like specifically when I like sat down and I was like, all right, today's the day where I try to learn what a conditional type is, because I have no clue. And, it's like, that was the hardest part, basically. Writing your first generic and then writing your first conditional type, those are two concepts that like, you just have to sit with them for a while, and you have to just start writing code and like tweaking things and playing with them. And then eventually you develop intuition around it. None of the terms for anything in TypeScript like are useful for really understanding what it is. Like, I think now with the benefit of hindsight, I could write up like a lot more intuitive version of how to do some of this complex TypeScript stuff and how to think about it, from like, writing a generic function and then constraining the input to that with the extends keyword, and then taking that inferred type and transforming it at the output of the function with a conditional type and things like that, and like how to really think about it. It's also just not something that, you may think you won't use it very much as an application developer as opposed to like a person writing a library, and you'd be right for the most part. But having access to some of these tools, like, it unlocks things in terms of how you're able to implement, like the elegance with which you're able to implement even things like, form validation or whatever. And, having some of that at your disposal, I would definitely recommend. Though, yeah, in terms of having like a nice comprehensive starting point for how to get into this stuff, this TypeScript advanced functionality, I'm not aware of anything except for the hit every branch on the way down approach. So, which I don't know if I'd recommend or not.
Yeah, Orta did a lot of work on the TypeScript handbook, so there's some good stuff in there, or there's a lot of good stuff in there. It's just one of those things where, I don't know, everybody learns a little bit differently, but there's a lot of the stuff I couldn't grok until I actually had to solve a problem with it. And, there are some things that, in hindsight, like conditional types, where it's like, at first I was like, oh yeah, this looks super simple, and then I started trying to use it, and I'm like, what is this? and then I got a handle on it. I was like, yeah, and come back around to like, yeah, it's not bad. But
yeah, it's not intuitive. Like, it's weird that they kind of use the extends keyword both in generics and in conditionals, and you can see the logic behind it, but like those two usages of the extends keywords are very different. And then there's just like when you can use infer and when you can't, and like how that inference actually works, which requires all this other back knowledge of like, the level of specificity with which TypeScript will infer a type. Like, if you just do like const x equals hello world, does that get inferred as a string or as the literal, like the string literal hello world? And like you need to know that in order to know, like, to mentally simulate how TypeScript will behave, like in all sorts of situations. And it's, it really is just a big bag of rules. And then when you get into building something like Zod, it's like a big bag of horrifying tricks that you have to use to implement, to do things like, like there's scenarios where I want the output of the Zod inferred type to be clean looking and not be some like crazy hairy mess of like different generic types. And so like I have this like flatten utility that's basically like a combination of, it's like a mapped type coupled with like this kind of identity type. And you like you just have to know that when you put these two things together, it takes some messy TypeScript type and kind of reduces it down to its like most minimal representation. That's like will look the prettiest. And like somebody found this out like in 2017 and posted it to like the TypeScript repo, right? And if I didn't find that, then I would have no idea of how to do it. And there's many examples of this kind of madness that are things you won't find in the handbook, but fortunately most people will never have to worry about. It's another ridiculous one. Removing that question mark from an object type is so obnoxious. You look at the Zod code base if you want to see how it's done. Yeah, kind of preposterously hard, honestly.
Yeah, I recently encountered that identity thing in a Stack Overflow issue, and I was like, wow, this blew my mind. It went from like hovering over the type, it's like just gobbledygook, to like, oh, that's the type I have. Mm-hmm. So yeah, definitely lots of those little tricks floating around out there.
Oh, yes. Certain things are going to get a little prettier in 4.7. This is not going to make anyone feel better, but you can now write additional extends clauses that follow that infer clause in a conditional type. So you end up with things that really look like word soup, where it's like, T extends infer U extends string, and so it's nice. There's a lot of like places where it'll clean up the implementation of Zod, but prepare for that chaos in a few months here, or 1 month, I guess.
I mean, it is an insanely powerful type system, though.
Oh yeah.
One of the things I always sort of like think fondly about TypeScript on is like string typing is A, non-trivial, but B, like I don't know of any other type system that lets you do the same sort of thing where it like will type the structure of a string. That was a hard thing to learn too, but like well worth it, especially. Do you use that in Zod? Is that a thing that you can take advantage of in Zod?
No, actually, this is a long-standing open issue as well, which is to try to have like a Zod, runtime implementation of template literal types, where like you can actually, in your template literal TypeScript types, you can say like, hello, brackets string, and you like now that has to be like the literal like string hello followed by, some set of digits or whatever, and you can't. Hard. Yeah. So like in terms of representing that, it would be some API where it's like, z dot literal, and then you pass in like an array of components that kind of get concatenated, and you'd be able to mix literal values and like z dot number, z dot string. Well, I guess just z dot number. I haven't looked into like the full spectrum of what you can represent with template literals, but in general for that kind of stuff, I usually say like just use z.custom, which lets you like provide any type signature you want, and then just pass in a function that uses a regex or whatever to validate that properly. That it's nice to have some fallbacks where every issue I don't need to necessarily address immediately. I can throw out the workaround and then buy myself some time when actually implementing it.
Cool. With that, let's move on to tooltips. So my first and only tooltip this week is about a new RFC to React, which is has been making the rounds, lots of discussion on Twitter and in my company's internal Slack. But what it is they want to add a new hook to the base layer of hooks in React called useEvent. This hook really solves a lot of the like dependency issues that I've found. Once you start using effects for things, you have to be very diligent about making sure that your dependency arrays for those effects have everything under the sun. So like if you're doing a thing like, say, in their example, they connect to a socket in an effect, if that connection is taking in things like a username or like any bit of information that might change, it needs it in the dependency array. And then because it's in the dependency array, that effect is going to rerun every single time that any of that stuff changes. What this useEvent hook allows you to do is you can now create these callbacks that have no dependencies, but will always have the up-to-date closure values of all the variables they're referencing. And then when you use those callbacks inside of effects, it doesn't actually need to be in the dependency array and runs how you think it would. We actually have this in our code base at Descript today. We just call it like useEvent callback. And it basically does the same thing where it allows you to have a callback that the reference to the callback never changes. So the effects in other callbacks that reference it in their dependencies array don't actually update ever. So it's kind of a hard thing to wrap your head around if you haven't been in the React hook world reasoning about this stuff. But I think it's going to really simplify code when it lands because dependencies suck. Hate reasoning about this stuff.
So the useEvent returns a function that you can then pass into like onClick or whatever.
Yeah.
If you declare that onClick event handler like inline, I guess that function gets like declared every time there's a re-render is the idea?
Yes, because with the functional components, the render gets called each time it renders. So you'll have a new function every time that component re-renders. And then if you're using hook stuff where like it's in a dependencies array, you now have a thing that's actually just changing every single time. And this solves that by making it basically creates a ref to the function that you can just use the ref and the ref doesn't trigger any of those updates.
Very cool.
Yeah. And if you don't want to reason about this stuff, go look at Solid.js. It's solid.
Yeah. It's like it continues to be somewhat of an issue that sort of grows a little bit over time is the cognitive overhead of understanding, when you need to cache references to things, when you don't need to. It's like I found that more and more it's more of a pit of failure than it is a pit of success. It's like your first intuition is most likely to do the wrong thing, and then you have to sort of work backwards from there to get to whatever the right solution is. And I don't know.
Yeah, whatever that ESLint plugin is that like auto adds all of your dependencies to use effect, like A, it's super great. But B, it is a little troubling that something like that is necessary to write code that isn't wrong,
Yeah. And then there's sometimes when like that's like rare cases where that's not actually what you want anyway. So it's just
Yeah. Like I loved hooks when they came out, but after hitting these issues over and over again, like I've never thought before like, oh man, I don't like React. And hitting these issues, you quickly get into I don't like React. There is some hope on the horizon though. At the last React Conf, they had this React automatic memoization project, which looks just completely bonkers. Like, please let me write my code. Yeah, React forget. Let me forget that React exists, and then you optimize my React code for me. Because I am tired of using use memo, use callback, memo, everything. Like, sometimes we have to memo children, which is just like,
Well, I look forward to seeing that land in a decade. Yeah.
My only concern with this is that we're just like piling more and more stuff on top to hide the fact that like some of the internals here are maybe not ideal. And again, this is for anyone listening. This is no shade on the React team because like the stuff
I love React
is amazing. Yeah, it's just I don't know, building something that like is interruptible, is schedulable, is
concurrent.
Like all of these. all of these really amazing properties and providing them in APIs that are like succinct and, you know, whatever else, non-trivial. So,
and just light years ahead of other things out there. Like, it's just a sign of maturity of React that these are starting to be problems, you know. But yeah, if I ever feel down about the current state of React, I just remember that there's no longer component should update, and I thank my lucky stars, you know.
Yeah, for sure.
Could be worse.
So my tooltip is this reactivity library. Speaking of solid.js, as reactivity library, this is written by Yehuda Katz, who is the creator of Ember, I'm pretty sure. Anyway, so it's a generic reactive state library, essentially, that's trying to give you, you know, Excel spreadsheet-like state management. You know, if you want to have a cell that's reactive and does stuff. If you've used Svelte or if you've used Vue or Solid, you know, this is a well-known concept to you. The interesting thing about this library is it's portable across frameworks. So they've got a React library for it, and they've got bindings for other languages as well. Yeah, I don't know. It looks pretty interesting. I mentioned the Excel thing because some of their terminology does sort of feel, you know, spreadsheet-y, and to me, I think is fairly intuitive. I think some of the newer reactive state management libraries take more of a like mathematical approach to naming, so they call things like atoms or you know, like to mimic like an atomic sort of interaction or whatever. Can be a little bit more confusing, I think. So I at least liked how they did the naming for here. Anyway, it's an interesting looking project, and I like the name. Starbeam just sounds futuristic. So.
It really is. That's a good get on NPM. One of the questions we didn't get to on our checklist here was whether or not Zod is named after the general. And yes, it is named after the DC character, but the real reason is that I wrote a script to bring up the list of all 3-letter NPM packages, and that was one of the only ones that was pronounceable.
Hilarious.
Yeah.
That's amazing.
I'm still sitting on ZIA, which was the other good one, which is like the state symbol of New Mexico. So if any New Mexican listeners out there have like a great idea for NPM library, then, you know, hit me up, because you can have ZIA. I will say as well, state management is like a big blind spot for me, where I kind of landed on one of the design decisions with my YC company that I was very happy with was choosing MobX early on. And now I feel like we're like 8 generations beyond MobX. I truly have no idea, like, I haven't dug into ZooStand or Starbeam or some of the newer things at all, which I don't really, it's a blind spot for me for sure. It's hard for me to even conceptualize something that I would like better than MobX, because it's just like, you just like write an object and pass it into a function to make it reactive, and then just start using it everywhere. Though you do have to like use a decorator around all of your React components to make them observers, which I guess is a bit of a drag.
My perception of the general trend here is like mostly pushing state further back to the back end. You know, it's like doing less. So, you know, using things like GraphQL Apollo or React Query or SWR or whatever else, these things that mostly do all the state for you, and then your state needs are reduced pretty greatly on the front end.
Yeah, React, you know, local React state and any fetching library, you know, gets you a long way.
Yeah, for sure.
Another thing I was trying to pull off that I think is still pretty tricky is this bit I was talking about, where you try to only have a single copy of every object from your database, like locally, basically denormalization, which is something Apollo client does. At some point, well, I guess I still do have a library called Normie that you just like pass. The idea is you pass all of your API, like all your fetch data through it, and it kind of looks for any object containing a property called ID, and just treats that as kind of a universal ID, and then like maintains the kind of like a single copy of that object, which is, you know, something I also spun out around the time I spun out Zod. I think it's an underutilized pattern for people who aren't using Apollo, which does it for you automatically. So my tooltip, I have a couple of them, but I'll start by saying I recently bought this saddle chair, this backless saddle chair. I don't know if this is even like a standard term yet. Like a lot of the things on Amazon are just called ergonomic chair, which brings up something that looks kind of like this. But it's really been a game changer, I gotta say. As someone who like has tried every gaming chair under the sun. I feel like this just like, it's like really hard to sit in with bad posture. And that's been doing a lot of good for me. Like at the end of the day, I feel like I've been engaging my like back and core a little bit, and it's like a good kind of tired, like, man, I'm glad that I like am actually using those instead of like being like in a prone position in my chair, basically like, with my lower back constantly under tension. Yeah, they look like the most uncomfortable thing you've ever seen when you look at them on Amazon. So just prepare for that. But it's been a huge win. Something that's maybe a little more relevant is I just want to shout out that TypeScript 4.7, the first RC is coming out in a few days. And the final release should come out by the end of May. And it's finally bringing us ES module support into TypeScript, which is, it's honestly kind of, I mean, it's been a disaster. They first announced this for the TypeScript 4.5. And like, even after they like put this out in the beta of 4.5, they then like rolled back on that and have now taken 2 more versions to actually get it out there. Yeah, it's pretty weird. I will say the thing that is exciting about it is it finally lets you use top level await in TypeScript, which I feel like I've been talking about for like a decade now, not actually, but like a long time. And you can finally just like write a .ts file. You have to like put type module in your package.json, or you have to title your, you have to use the .mts extension for your file, which, is probably going to turn off everybody right out of the gate. But you do kind of get used to it. And it really does finally make TypeScript feel like a query language or like a scripting language where you can just like start, like the first line of your script can just like be fetching something with like an await, like, fetch something remotely with an await keyword without needing to like write a function and then call it, at the bottom of your file or whatever. So I'm excited for that. It's pretty weird, like I mentioned, where because ES modules require file extensions on imports, and coupled with the fact that TypeScript, like for some reason, refuses to ever like rewrite the extensions of any import in your TypeScript files, you actually are importing like from foo.js or whatever, even though like the file that is actually getting imported is foo.ts. And so I don't know if this is a tooltip or like, me just kind of like, it's gonna be a weird rollout here. I don't know if people are gonna like it or not, but I'm kind of excited for this all to play out.
Yeah, the extension thing is odd. Like I've written a few projects that are TypeScript and ESM, and adding JS in my TypeScript files feels very weird. And if I start having to add MJS, CJS, MTS, that's all the different extensions they added are wild. Like .d.cts, like some junior programmer's gonna find that and just be like, what the hell is this?
I know. I finally had to bite the bullet and finally understand CJS versus ESM and how all this works with the node resolution and stuff for work, actually for the query builder stuff at EdgeDB. And gosh, it's fun. It's nice to know now. It's a nightmare. It's a disaster. I love it.
Yeah, it's really unfortunate. This reminds me a lot of the Python 2.7 to Python 3 sort of transition and how sort of painful that was. It's a little different, I guess, but like this is going to be pain for the ecosystem for many years to come, unfortunately.
And it has been.
Yeah.
Yeah.
I literally last week finally like dug deep into my bash profile and finally changed it so that just Python on the command line uses Python 3 instead of Python 2.7. So that's an ongoing battle for sure.
And the last tooltip of the day.
Yeah, my third one is a nice quick one, which is I've been using TS Node to execute files for a long time. This kind of goes hand in hand with the ESM stuff in some sense, because you can, Dino now has a great experience where you can just write .ts files. Also in Dino, when you do imports, you're able to import with a .ts extension, which is kind of an interesting testament to the fact that Dino is kind of more committed to being TypeScript first than TypeScript is, where like you don't need to like do this weird import with a .js extension, which is what you need to do if you're using plain TSC. But yeah, basically I've been using like npx ts node to execute TypeScript files for a long time. And even if you have like a one-line file that just like does console.log hello world, it takes like 3 or 4 seconds for me. And I recently learned that you can just put -T or -- transpile only to just disable type checking. So it will still run even if your code has compilation errors, but it runs it like sub-second now, which is just so much nicer if you just want to like write some TypeScript file to, some script to do anything. Literally just like shaves off 3 seconds of like, I don't even know what it's doing, like why it needs to spend 3 seconds doing type checking on a 1-line file that just logs something. So maybe that's room for improvement on the TypeScript compiler side, but for the moment, tsnode -T, it's doing it for me.
Tooltip rebuttal for you.
Yes, build.
Use ESBuild. This is actually something that Justin showed me, and I use it everywhere, and it's super simple. You can just use this ESBuild register, and you just do node-r, and then you're off to the races.
I was looking into different options here, and I saw the ESBuild runner, which is actually should do roughly the same thing, and it's at least like a little more expected for me, which is like npx ESBuild-runner. And I almost used that instead. There was really no reason why I went with the -T thing, except that like, at the end of the day, it's almost the same because ESBuild doesn't do type checking either. And they were pretty similar for me in terms of like compilation times on this 1-line console.log thing. But clearly I'm going to be the last dinosaur using tsnode, and you're going to be there like, wow, can you believe that's just embarrassing? Yeah, everyone else is on ESBuild, so.
Yeah, the -R flag passing to node is just to require something. So you can actually do this for like anything. If you ever need to require a global module when you're running node, you can just node -R and have it require something.
Do you need to have it locally installed, or will it install it kind of for you npx style?
You need to have it locally installed.
Locally, cool. But yeah, the ESBuild runner, like you can just run it with npx without having to install it globally. And I looked up, like I Googled npx ESBuild-runner in quotes on Google, and there's only one person on the whole internet. Like it was literally one result on Google. I don't understand why this isn't like the go-to, for just like recommendations on the ESBuild-runner docs, but they like really want you to install it globally. I don't understand.
Well, yeah. I think that thing you're saying is like, well, do the -T flag to save a few seconds on running your script. Well, if you're running something from npx, it's really, you're going to have like more than 3 seconds for sure to be able to execute your script.
The first time. Get out of here. Yeah. Just once. Though I don't know if that's actually coupled to where you are in the file system at the time. If you move to a different spot, does it re-download? Maybe.
I'm not sure.
Yeah. Something to figure out before next episode. Yeah.
Indeed.
Okay, well, I think that about wraps it up for this week's episode of DevTools-fm. Thanks, Colin, for coming on. This was a fun talk about some very complex TypeScript topics. You are probably the biggest TypeScript wizard that we've had come on here, because each project that you do is just like crazy TypeScript stuff. So thanks for coming on.
I certainly hope that it doesn't get more complex from here, because I'm not sure my brain can take it. But thank you so much, guys. This has been a blast.
Thanks, Colin. It was a great time.
Well, that's it for this week's episode of DevTools-fm. Be sure to follow us on YouTube and wherever you consume your podcasts. Thanks for listening.